Hello, welcome to Stars, Cells, and God. My name is Jeff Zweerink. Today I'm joined by Dr. Hugh Ross, and we're going to be talking about design in the Tibetan Plateau and some worldview implications of AI development. Well, welcome, Hugh. It's good to have you here today. I will just throw the floor over to you. I'm curious what sort of design features the Tibetan Plateau has, so go ahead and take it away.
Well, it's a new measurement. So they discovered a new feature based on a measurement that they thought that they could never achieve, but they pulled it off. It got published in a new issue of Science Advances, literally just published days ago.
Okay.
And what these scientists did is they went into a place called the Qaidam Basin. And we got a map here to show people. The arrow basically shows you where the basin is. It's a big basin kind of in the north east part of the Tibetan Plateau. And the Tibetan Plateau is about 1 million square mile region, 2.5 million square kilometers if you're into the metric system. So, and it's the biggest uplift that's ever happened in Earth's history.
So 1 million square miles, that's something on the order of the area of the United States, because I know the United States is about 3,000 miles across. This is a very massive or a very large area. That's kind of the point I'm getting
compare
at
it with,
there.
say, the contiguous 48 states,
Right.
it's about 1/3 the area.
1/3 the area of the contiguous United
Yes,
States?
Right, yeah. 3
All
million
right.
square miles.
3 million square miles.
Yeah.
Seems like it'd be larger because the U.S. is about 3,000 miles across. There'd have to be 3,000 miles deep to make it 1 million square miles.
Yeah, well, the U.S. is about 1,000 by 3,000.
All right, okay.
Yeah, roughly.
Very good, okay.
Okay.
So anyway, very large
it's
area.
a huge
It's
area.
not a trivial area.
And its current uplift has an average of 17,000 feet. So,
Okay.
I mean, we're talking a really big uplift. And, geologists have understood that what's responsible for the uplift is the Indian subcontinent breaking off from, Madagascar about 65 to 70 million years ago, and then speeding at a high rate towards Eurasia. And
I'm assuming a geologically high rate.
22 centimeters a year.
Ooh, blazing speeds there.
Well, it is a blazing
know it
speed
is.
because a normal speed is under 2 centimeters
Right.
per year.
Yeah, it really is
Any-
fast.
And so this is the fastest tectonic plate movement that's probably ever happened in Earth's history.
Right.
And so we have the Indian subcontinent crashing into Eurasia, and that created the Himalayas and pushed up a huge area north of the Himalayas. And that's basically the Tibetan Plateau. The southern edge is defined by the Himalayas, and then you got this plateau above it. And the Qaidam Basin has got mountains north of it and mountains south of it. I mean, it's basically surrounded by
Right.
mountains.
And, that's just, and there's a part of that is very impressive just because you look across the continental United States, the contiguous 48 states, there's no place in the continuous 48 states that is higher than 17,000 feet.
No.
And this plateau is 17,000 feet.
On
That is
average.
remarkable. It's just something to me that as I think about it, it is very unusual and remarkable and just in and of its own right.
Right. Well, geologists have been able to measure quite accurately the history of the rise of the Himalayas. I mean, even today, the Himalayas are going up at an average of 17 millimeters per year.
Right.
So Everest gets harder to climb every year because it gets a little higher.
I don't think that adds a lot, but okay, I'll give you
17
that.
millimeters, yeah. So, but what they've been lacking are really good measurements of what's happening north of the Himalayan range. And so this paper, a bunch of scientists went into the Qaidam Basin. The arrow shows you where that basin is. And they were able to dig out 90 mud samples across this basin.
Okay.
And they basically used a temperature proxy. And these are chemicals known as alkenones.
So what is it they're trying to measure? That's unclear to me where we are
Well,
at this
they're
point.
trying to measure the temperature rise that took place in that basin historically
Okay.
and use the temperature rise to determine the elevation rise.
Okay, so they're trying to figure out how quickly did this all happen? How quickly did
Right.
the Tibetan Plateau rise as the
Right.
Indian subcontinent was
So
colliding
they're
with Eurasia?
basically
Okay,
using the temperature decrease as a way to measure the
gotcha.
altitude
All right, that
increase.
makes sense.
And they chose mud samples because they realized these would be paleo lakes.
Mm-hmm.
So these would be ancient lakes that existed in that basin.
Okay,
There's very few lakes there today, but in the past there were significant lakes. So they purposely went after the mud samples because they knew that would be the floors of these lakes that existed a few million years ago. Then they used the alkanones, these chemicals, as a temperature proxy to determine, okay, what are the temperatures in these mud samples, which they were able to date
mm-hmm.
and basically determine that the mud, the layer of mud at the bottom of the water, the temperature cooled by 6.6 degrees centigrade over a period of 500,000 years.
Okay, so the basic idea is you can go in and at various places determine when this temperature measurement or when this temperature occurred. The temperature has the temperature at the bottom of the lake has a impact on the amount of these alkanones and how they play out in there. And from doing that, you're now able to extract a date and a time or a date and a temperature which correlates with an elevation, and so you're able to map out the elevation
Right.
change over. I mean, so you said this happened 55 to 70 million years ago is when the Indian subcontinent collided?
That's when the continent collided. The
Okay.
plateau rose quite a bit later.
Okay, so this
And
is
so-
somewhere in that 65
Well,
or
they're
65 million
measuring
years
a
since.
temperature range from about 12 million years ago to about 6 million years ago.
Okay,
So that's the date range they're going after,
okay,
because that's when these lakes basically disappeared, and what they're measuring. And they purposely chose the mud below the water, the top mud layer,
mm-hmm.
because that's where the temperature would be most stable.
Right.
I mean, water at the bottom of the lake has a much more stable temperature than water
Oh,
at the top of the
absolutely,
lake.
yeah.
So they were able to get, on that basis, they're confident they got a reliable temperature record,
Mm-hmm.
what was going on during that period. They did have some.
Were they able to? I mean, so I was just curious, and they may not have talked about this in the article, but it does seem to me you're going to have layers of mud built into the lakes. Can they use the history of the mud layers in the lakes, or is it just the top layer they're able to use at this point?
Well, they took 90 different samples, so they're using different lakes
Right,
over the
of
whole
course.
basin, and you're trying to date them, measure the temperature, and so that's where they get the record.
Right. Okay.
Now, they had two different models that they were using. One that places rapid temperature cooling at about 11 million years ago, and one at about 7.6 million years ago. And so they're basically saying one of those two dates is correct. But as I read the paper, the evidence seems to be more favorable to this event having 7.6 million years ago, depending on 11. And it's all based on the fact that the proxies give you two possible answers.
Right. No, that makes sense.
So, but I do think the 7.6 million year date is probably the one.
Did they give an explanation? Because if you assume that the Indian subcontinent has been colliding with Eurasia over the last 50, 60 million years,
Basically over the past 25 million.
okay,
is where
about 25 million years.
Yeah.
I would naively just kind of expect the Tibetan Plateau to just gradually rise during that time. Did they say why it seems to rise so quickly at these in these two particular
Well,
possibilities?
The paper makes the point that with the collision about 26 million years ago, I mean, the collision's been going on for, about 30 to 35 million
Right.
years ago. But what's happening is ocean floor between the Indian subcontinent and Eurasia is getting crumpled. As the collision continues, that crumpled up seafloor becomes above sea level, and then it becomes the Himalayas.
Okay.
So, and what they're able to demonstrate is the Himalayas will form first, because that's the point where the collision is hitting.
Right.
So you get this rapid rise of the Himalayas, but the Indian subcontinent is still colliding with Eurasia. Right now is moving north at 5 centimeters per year. So the collision is not over, it's still happening. The Tibetan Plateau and the Himalayas are getting higher and higher with every year that goes by.
So this is something akin to if you collide in a car, you're going to crumple up the front first,
Right.
and depending on the severity of the collision, eventually stuff behind it is going to get
Yeah, like human beings, for
So
example.
the crumpling of, or the uplifting of the Tibetan crust is a later aspect of the crumpling that is going on because of the collision.
Well, they've known for some time that the latest event in the collision is the rise of the Qaidam Basin.
Okay.
So that's why they focused on that. They said that's the last major event. I mean, there's still stuff going on today, but the last really significant event was the rise of the Qaidam Basin. But for the first time, they're actually able to measure the rise by getting these good temperature proxies.
Right.
So they're able to translate, okay, if we're talking 6.6 degrees, and that works out to 12 degrees Fahrenheit, if you want to use a Fahrenheit temperature scale. So, but they're also able to determine that this temperature cooling happened quite rapidly in less than 500,000 years. So in less than 500,000 years, the temperature of the Qaidam Basin literally dropped by 12 degrees Fahrenheit.
So presumably that's because it was going from, I don't know what it was, up to the current 17,000 feet. Just as it rises, it's getting colder, and so that's what it's measuring. And over 500,000 years, this pretty dramatic elevation change happened.
Yeah, you have the Qaidam Basin at still a decent elevation, but because of this ongoing collision, there's an event where you get a rapid rise.
Right.
And that rapid rise happened, I believe, 7.6 million years ago.
Okay.
Because I think that's got more data behind it than the 11 million year date.
But either way, whether it was 7.5 or 11 million, this dramatic event where it rose dramatically happened within 500,000 years.
Almost all the rise of the Qaidam Basin happened within that 500,000 year window. So we're talking, a major tectonic disruption in that area and pulled the whole basin up. And that basin is the lowest elevation region of the Tibetan Plateau. So pushing that up dramatically does have a significant temperature effect on the whole Tibetan Plateau.
No, that makes sense.
And they're able to determine that it rose by 1,650 meters. So that's a little more than a mile.
1,650 meters, yeah, so that's just right around 5,000 feet. So that's significant.
Yeah, talking 5,300 feet of elevation rise happening that quickly. And that basically formed what we now know as the third pole. So you got this 1,000,000 square mile area where it's high enough up, even though it's close to the equator, the altitude is high enough that you basically get snow and ice permanently residing over that region.
Well, so I mean, I get the implications of that, but you talked about the Himalayas. I presume that's the Himalayas would play into this third pole region as well. Are they just a smaller area, or why is the Tibetan Plateau
Well, the
so
Tibetan
important
Plateau
there?
is important because, yes, you got the Himalayas, they're sitting around 20,000 feet.
Right.
It's going to be covered with glaciers. But the Tibetan or the Himalayan mountain range is still a relatively small surface area.
Okay.
So the fact that the collision is pushing up this enormous plateau north of the Himalayas means you got a much bigger high altitude region that's going to accumulate snow and ice. And the accumulation of snow and ice and snow are highly reflective.
Right.
And so the fact that it reflects light back means there's a possibility of getting even more snow and ice accumulating there.
Well, and this also is kind of closer to the equator than either the North or South Pole, so it has a much larger effect. The more surface area has a bigger effect there.
In fact, it's about a factor of 4 more reflectivity because of its location close to the equator.
That makes sense.
Than the reflection you get at Antarctica or around the North Pole. And because of the amount of ice and snow that's there currently, geologists refer to this as Earth's third pole. In fact, what's interesting is that...
It's just a weird phrase, but I get what it's going with.
Well, it's a third major region of ice coverage.
It does make sense.
So, in fact, the ice coverage there in the summertime is greater in the Himalayan and Tibetan Plateau area than in the North Pole region.
Right. Okay.
So, in fact, it ranks third in ice coverage. You got Antarctica first, Greenland second, Tibetan Plateau is third.
All right.
And then the North Polar Cap would be fourth, although in the wintertime it gets a little bit beyond what you got in the Tibetan Plateau.
Gotcha. So, okay, so this is just from a geology perspective really cool. I assume there's an apologetic significance to this as
There
well.
definitely is, because if you want to have humans on planet Earth, you need to have humans here when the sun is about halfway through its nuclear fusion, its fusion of hydrogen into helium. And the reason for that, that's when the star has its most optimal luminosity stability.
Okay.
So as stars age, when they're young, they're very unstable in their luminosity. When they get old, they're unstable in their luminosity. When they're precisely middle age is when you get the optimal luminosity stability. And we need that if you want to have global human civilization with billions of us running around.
Okay.
You need the sun to be very stable, but it also means you need the sun to be about 4.5, or 4.57 billion years old. And when it gets that old, it gets bright because the sun gets brighter and brighter as it continues to fuse hydrogen into helium.
Right.
So that means if you want to have humans with a stable solar luminosity, you got to have them here when the sun is about 23% brighter than the event of the origin of life. So you need a means to cool the planet sufficiently because we need a relatively cool planet and we need the sun to have stable luminosity. So we need something that's going to keep the surface of planet Earth cool enough when the sun is in its most optimal luminosity stage. So that's why you need a third pole.
Yeah, it's interesting discussing that because, you look at the Earth today and you take away any sort of greenhouse heating and the Earth is so cold that all the water freezes. And so, it seems like we're kind of on the low end of just barely being warm enough. And yet here you are talking about the sun is almost too bright for what we need. I've just been, in doing some research for a book I've written, kind of looking at the history of the Earth, that it seems like in the history of the Earth was a lot warmer, even though the sun was less luminous. So there's almost some of this where what we expect, or what I would expect scientifically, the sun's dimmer, it's going to get brighter. That means the Earth is cooler, it's going to get warmer. It almost is backwards. It's like God's working things out in a different way, not just to barely have it there, but to work towards something that's more
you're
optimal
referring
later.
to the Eemian. It's a geological era when Earth was significantly warmer than it is today. Interestingly, that particular epoch is before this event.
Right.
So it's basically saying, hey, yeah, without that third pole being intact, you got a planet that's too warm. And we would not be able to survive during the Eemian. Well, we could survive, but we wouldn't have global civilization.
Right.
We couldn't have a large human population. Only a few of us could be saved because only a few of us could even exist here.
Right.
And so we have God basically bringing about this third pole to deliver us from the Eemian catastrophe. So that cools the planet dramatically, cools the planet enough. And I think you're making the point. If the planet's too cool, we got a problem. If it's too warm, we got a problem. And so what we have here on planet Earth is an optimal temperature happening to coincide with a moment when the sun has the least flaring activity and when it's the most luminosity stable. But my whole point is, without this very fine-tuned development, the growth and the building up of this Tibetan Plateau, where most of it's covered with snow and ice, we wouldn't be able to have billions of us living here with the technology where we could all hear the gospel and be redeemed from our sins. So it's like God was setting everything up so that his plan of redemption could be fulfilled. And so it's like we need this event to happen. And what I also find interesting, the history in which it develops is also crucial.
How so?
Well, you want the pole to develop in such a way that it gets to its maximum extent when we show up. So the plateau is continuing to rise, which means that if we extrapolate into the future, it will get higher and higher, which means that each ice age will become more and more severe.
Okay.
In fact, we see that in the last 8 ice ages. each successive one's been more severe than the previous one. So the last ice age was the most severe of all.
Okay.
That was a good thing for us because the severity of the last ice age meant that you got an extra buildup of ice, and the melting of that ice during the interglacial is basically watering the great agricultural plains. So it's great that we have all this ice, and because with the interglacial and this very severe ice age, you get a rapid melt event, and the rapid melt event basically fertilizes the agricultural plains. So they get the water they need, they get the fertilizer they need, because of the rapid melt, you get powerful winds blowing, nutrient-rich dust off the high plateaus onto the low agricultural plains. You get volcanic eruptions happening with a rapid melt, and that also serves a role in fertilizing the great agricultural plains. I mean, it's a reason why people like to have farms near volcanoes, because the soil is so nutrient-rich. So,
I do find it interesting as I know the Earth is a dynamic structure, but how elegantly its systems work together. It's like you kind of assume, the plains are always going to have a lot of nutrients. Well, the more stuff grows, the more the nutrients are depleted.
Right.
Yet there are these elegant mechanisms that God has put in place to
Replace.
distribute things around. I mean, we see that in the oceans, that the oceans get stirred
Right.
up instead of all the nutrients staying at the bottom. Even just the continental cycle of earthquakes and volcanoes and stuff. This idea of moving the nutrients around to where they are, it works phenomenally here on Earth, and I think I tend to take it for granted how well it works, I guess.
Right.
So.
Well, the other thing that caught my attention in reading this paper is we have this event happening very rapidly in less than 500,000 years, and it's a dramatic uplift, more than a mile. That's going to be accompanied by major earthquakes throughout that region.
Right.
And so you want that happening far enough back in the past that it's not going to be a factor in disrupting human civilization. And putting it back 7.6 million years ago, that's about the right epoch you want to have it, which means that,
No, I was just joking.
Things
It's
have
this is all
stabilized
over.
enough.
This is all over in Asia. God could have just had people originate down. I'm joking. Yes, you're right. I mean, these are presumably earthquakes that are pretty catastrophic in the region there. I'm assuming they don't have global consequences in that fashion.
They don't have global consequences, but we're talking magnitude 10s, maybe even 11s, happening very frequently.
Considering the largest we've seen in recorded history, I think is 9.5. That's remarkable. So,
Yeah,
and
it is.
And that is a mammoth
And every
earthquake in and of
bump
itself.
up is a factor of 10.
Right.
And, when you talk about a magnitude 9, that's enough to shake the bark off trees. So it's like if you multiply that by 100 times, you got something you don't want to be around.
I agree.
So, but yeah, we're not talking, say, disturbing events in Australia or South America, but it would be a major disruption because Asia is the largest continent. It would be disrupting the flows of rivers if that was happening today. And so it wouldn't be just the region of Tibet. Given that you got 20 major rivers flowing out of the Tibetan Plateau that are crucial for feeding human civilization, those events would have a ripple effect far greater than just 1 million square miles.
So it seems like there's an aspect of this event needs to happen, and you want it to happen as early preceding human history as possible at some level, or that's kind of what you want. But you also want the catastrophic effects or the things that would be detrimental to humans to have worn out before then. And so it's a little bit of optimizing all that to make it.
Yeah,
the
you
fact
don't
that
want
it's
it
7
to
million
happen
years ago.
too far in the
Right.
past, because if it's too far in the past, that means you don't have the ongoing. It's
Right.
important that we still have the Tibetan Plateau going up. That would have disrupted the Ice Age cycle in a way that would have been problematic for human civilization. So look at that 7.6 million years and say, that's the optimal time to have this major uplift. And, good thing that happened 7.5 million years ago, because now you still get earthquakes in that area, but it's not going to be catastrophic to human civilization. And yet we got the benefit of this huge high elevation plateau.
Just out of curiosity, does any of that argument change if it turns out to be 11 million years ago?
Not that much. I mean, I think the 7.5 million is a better date. based on the data. And it's also, I would argue, more optimal for humans. But if you push it back to 11, that means, okay, that probably means that you got more uplift happening after that than what we see. I think the 7.6 million year date is probably going to be the date we land on. The authors agree that's more likely than 11, but they're basically saying we can't rule out the 11. But yeah, it'd be different, but not that much different.
So in some sense, the argument that it's optimal is not that it was 7.5 million years ago. It's that it happened long enough ago that we see the effects that are important today. And whether we understand how to get from the 7.6 to what we see today, or it's 11 million to today, you still got the same sort of effects going on today that are important. So the optimality is in what we see going on today and knowing this had to happen in the past.
Yeah, and I think the rapidity, the fact that it went up so quickly over just a 500,000 years, means that the benefits from it are going to show up quickly, not slowly.
Right.
So. But that's it. So
Nice. Well, that's a fast. Like I said, I am just from a geology perspective, I find stuff like this incredibly interesting, and so the apologetics implications are neat as well.
Well, the idea that you got a third pole near the equator is just incredible.
Right.
The size of it is 1 million square miles, and just happens to happen at the right time. And and I just see also incredible design. How you get a supercontinent, a subcontinent moving that fast.
Yeah.
How do you get it to move 22 centimeters a year? And we now know why the Indian subcontinent has got the thinnest lithosphere of any of the continents. It's incredibly thin, and because it's so thin, it was able to move very rapidly from Madagascar. And if it moved slowly, we wouldn't have the benefits we have today.
No, it makes sense.
And by the way, it's also been a huge benefit for the Indian subcontinent
Yeah.
because that collision basically caused these Indian subcontinent become more fertile because there was the ignition of different volcanoes.
Yeah.
The wind flow actually benefited the Indian subcontinent. And the nation of India is now the largest population in the world. It's got a little more than 1 million square miles, yet they can feed everybody. And they can feed everybody because the soil is very nutrient rich, and it's all thanks to this geological event.
Well, I mean, that sounds similar to the Central Plains region of the United States or the Mesopotamia region. There are just places that are incredibly fertile because of the geologic events that occurred. The same is true there in India as well, as it sounds like. So,
all right.
Any other comments?
No, that'll do it. What's going on with artificial intelligence?
Well, I had two,
two papers,
two that seem very unrelated, but there was this, as I was reading them, I'm like, oh, that's an interesting thing. So one is they were looking at a group of people had developed an AI-powered lab, and I think if I remember reading into the paper, what they were trying to do is generate materials to make quantum dots for study. And so what they're doing is trying to experiment on different kinds of materials, different kinds of structures, make them in a fluidic environment, in a fluid environment. And so they were trying to, or the way you generally go about this is you make them, you test them, you go back, you do more tests and stuff like this. So what they decided to do was to build a lab that could do these things, or to automate this process. But
let me stop you.
Yeah.
Tell us, what are these quantum dots and why do we want them?
I'm going to draw a blank on that. I was more interested in how artificial intelligence was applied to this. But honestly, to be honest, I've not investigated why we use quantum dots enough to give an adequate description.
I'm guessing they have an application in making really tiny computer things. So
that wouldn't surprise me. I know you're manipulating things at a small scale. There are things that you can do. So I mean, I know that area of research is very fruitful. I don't know the specific aspects of it, but what they found is that in doing this, there's just a lot of different chemical combinations, figuring out what's going on, and it's just very time consuming because you have to do that, let the reaction take place, and then figure out what the next step was. And what they ended up doing was two things that made this happen a lot faster. One is they figured out a way to characterize the chemical reactions while they were going on. So instead of getting one data point at 10 seconds after the reaction had gone, they were able to get data at every half second. So they're basically making a movie of the reaction instead of just the final reaction. But then they also incorporated this into a system where an AI is analyzing all of that data and then determining what are the next experiments to perform. And the title of the article, this AI-powered lab runs itself and discovers new materials 10 times faster. And so they're looking at this from the standpoint of by being able to make measurements more quickly, increasing the precision and the resolution of the measurements, they can run fewer reactions, characterize them faster, use the AI to get the data, feed it back in more quickly, and it speeds up the process. So there's an efficiency to it. But I think even more importantly than that, one of the main reasons they were driving this is just for a sustainability aspect, is they were able to use far less resources to generate the new materials. And what struck me or stood out to me about this is that these are the sorts of things that often scientists are thought about doing. I was thinking of you've probably seen the movie, I think, Hidden Figures, where they're putting, launching a rocket into space. And one of the key figures in that movie was Katherine Johnson, who was able to do all the calculations and figure out some mathematical techniques that applied to do the calculations and get them solved. And, remarkable accomplishment. But I look at in fact, they were called human calculators. It was part of their the names for them. And now that sort of skill set in science for people doing it is largely useless, if you will, because my handheld calculator can do all of those calculations far more rapidly and more accurately than any person can, far more cheaply than any person can. And even now you start adding in the AI where you've got access to different mathematical techniques, and what used to be a scientific job is now a job that's relegated to a piece of technology. And I was just kind of wondering how many as we continue to develop AI, that a lot of things that scientists do, in fact, a fair bit of what I do science is, how do I make these pieces of equipment get me the data that I want? And I'm not sure how much of that requires original thought, if you will. It requires a skill set that I've developed, but it's not original thought in some sense.
Just hearing you talk about this experiment, basically what they're doing is using AI to say, we know that's going to be a failure. We don't have to run those experiments, or we can run them faster. And AI systems don't get tired where they need a coffee break like scientists do. So you're saving time, and a lot of science is driven. Okay, let's see what fails. So if you can use AI to avoid the failures, or at least some of the failures, you're going to save a lot of time in your research. So I think, as I understand what you're saying here, this is an AI system that speeds up scientific research, avoids us going off on tangents, and because of the speed of the system, it achieves its results faster. You still need the human controlling things.
That's the part that I wonder, is that, the idea of building an AI that could do this 20 years ago, you'd say, oh, no, we're always going to need humans to do that. Well, now we've got AIs that can do things that we thought only humans could do. My question is, if we're driven primarily by efficiency, and I'm going to come back to that point in a few minutes, if we're driven only by efficiency, how quickly can we do what we're trying to do? We may be missing the things that only humans can do, because I don't see any aspect of this. This is working, I think if I remember correctly, it was working with cadmium and selenium quantum dots, that it wouldn't surprise me that you could just say, hey, I need this kind of quantum dot, and your AI will drive the lab and produce it. And so all of the people that would have normally had the expertise to do that are in a very real sense replaced by this piece of technology. What I find interesting about this technology, though, it wasn't saying, here's how to do all the experiments. There was some training in there, obviously, but it was more, this is the goal we're going at, go do that. And so I think that's probably the part that humans are only going to be able to do. Although even in figuring out what the goals are, often in there's an algorithm I use to figure out, in my head, there's an algorithm I use to figure out, okay, this is what needs to get accomplished. And then I go about working in the lab to do that. It's not clear to me that AI will not be able to replicate most everything we do in science. And so there's part of that I find fascinating and discouraging at the same time.
Well, I'm kind of more optimistic. I'm encouraged because it's like we've had AI for a long time. I mean, now we got automatic elevators that don't need a human being to get the elevator to go up and down.
Right.
You mentioned the calculator. That was a huge time saver. I remember the days when we didn't have calculators, had to use slide rules. And so these electronic calculators were a huge time saving.
Oh, my field, the field of gamma ray astronomy that I did, if you don't have computers, you can't do that field because the data is so intensive, you just can't do it.
Exactly. So every AI advance is making us humans more efficient, is delivering us from routine, monotonous tasks and focusing on the stuff that only we can really do. But what we're discovering is our AI systems are actually now able to do things that in one sense are routine, but they no longer need our help. And it's like, I'm thrilled with AI because every AI step is making me more productive. I can do so much more in a brief period of time than I could do before. And I think that's not going to end. We're going to continue to be more productive, and we're going to be able to deliver people from, complicated routine tasks so that they can be set free to do other things.
I agree with that statement, and that's the part that I think, or what I would advocate. And I think it seems like I'm being discouraging, and more what I'm saying is the more we are set free from routine tasks. One, I find that very often the routine tasks help us remember what's important.
True.
And if we're setting ourselves free from the routine tasks, we're losing that tether to what's important. The other AI related article was, as AI is being able to analyze images and look at things, that it's able to characterize and describe images as well or better than humans, or it's at least approaching that. It's in the same class at this point in time. But what they were recognizing is that there's another skill that humans bring to looking at things that AIs don't do yet. And one of those is what they notice is that when a human looks at an environment, and it was talking about affordances, and I think if I understand what affordances means, is like when you look at an environment, humans can look at that and say, I know how I can traverse that. How can I get around in that environment? So when we look at an ocean, we know we're not going to be walking around in it. We're going to be swimming or dog paddling, or we're going to have to build a device. We do that automatically. So we don't look at that and say, oh, how am I going to get around? We look at it and we say, okay, this is how you get around. And AIs don't do that. It's, in fact, what they're able to show is that when you look at how the brain analyzes and does things, that the things that allow us to know how to get around are not well characterized by AIs that are trained in how to recognize what's in the image. So we don't look at the image and say, oh, there's a tree, there's a road, there's a grass and everything. Oh, therefore I can use a bike, or I can walk, or I could use a car, or I could fly. We just look at that, and given the environment, we just know those things. And so there's this capacity we bring to analyzing a situation that our current AIs don't do. Now, I don't think there's anything in the AI that is a limitation in putting that into the AI. So I think that's going to be something we will get. But it does kind of raise your point, or goes back to your point, is that there is something we bring to this game, whatever the game is, whether it's figuring out how to build new materials, how to determine how the Tibetan Plateau is rising. There's something we bring to that game that is different than what AIs are going to be able to accomplish. The question in my mind is, as we become more efficient, we can use that efficiency poorly if we're not careful. I mean, we're an apologetics organization. We produce content that helps people see the truth of the Christian faith. We write letters to people. We correspond with our constituents. We could use AI to generate all of that constituency correspondence, but we may be missing in there that primarily what we're trying to do is build relationships. And this is where, as I've been studying creation, we've had these discussions of what happened at the fall is that, one of the things God blessed us with in creation is often characterized as a command. I think it's a command, but it's a blessing of God, is that we're blessed with fulfilling the command of being fruitful and filling the earth and ruling over it and subduing it. Be fruitful, multiply, fill the earth, rule over it, and subdue it. That we are to continually be learning how to do that and to build relationships as we do. And if we use our efficiency to increase our expertise and do the next thing, then that will be great. If we use our efficiency to be leisurely and waste time and be more sedentary, it's going to be wrong. And so this is where, not that I'm saying AI is bad, let's shut it down, but let's ask the question, are we using AI in the efficiency to allow us to do the things that are important, or are we using the AI to do the things that are important so that we get distracted on things that we're not designed to do?
Right.
And I think the Christian faith has a great way of providing an avenue to do that, because I could see, so I was reading a book by, I think it was Mac Texmark, but he's echoing sentiments of many people that the beauty and the value of humanity is our intelligence, our sentience, and ultimately this is going to disappear in the world, but the longer we can keep it around, the better it's going to be. Well, I could see from an AI perspective that, well, if our sentience and our ability to learn, we can teach the AI how to learn and continue to grow and solve problems, that you could make an argument that will be able to progress longer the less humans are around to use up resources on the planet. So in that worldview, the best thing to do would be to minimize the number of humans on the world, which is exactly counter to what Christianity is saying. So we all have this sense that human beings are important, but now this question of why do we justify or why do we ground that humans are important or valuable in and of their own right, and every human is important, becomes far more relevant, because it seems you end up in some sort of utilitarian view if you don't take something that has the Judeo-Christian view. And so I think worldview, as we're building AI, the worldview that Judeo-Christianity brings is really important to using it well.
Well, you started off with Genesis 1. I mean, God basically said, look, you humans, I want you to manage the planet. Mm-hmm. I want you to control it, subdue it. Mm-hmm. And so he gave us all these amazing animals that we could use for agriculture. It's also something we use for relationships mm-hmm. amongst the animals with ourselves. And so it's to our best interest to take good care of those animals. Mm-hmm. I kind of look at AI the same way. It's a tool that God gave us.
Right.
But he said, I want you to manage it, be in control of it. Don't just let it run loose. Mm-hmm. I mean, letting your sheep run loose means that, some coyotes are probably going to get them.
Right.
And they're not going to be as productive for you. So you want to manage them well, take good care of it. And, take your scientific calculator that came out, in the 60s or 70, I guess, 1970, they came out. It's like the people that are able to get the most productivity out of a scientific calculator that you can buy at Walmart for a few dollars mm-hmm. are those that actually know the math that's behind it. And so,
absolutely, and that's actually, I think the point you're getting at there is something that I think I want to encourage people to keep in the forefront, is that the tool helps you do things faster.
Right.
But if you learn to use the tool without understanding how it works, it's going to be a limitation on you.
It will be.
I do agree that, taking care of the animals, managing AI, that's important. But I think I am more and more drawn to the conclusion that one of the things God wants us to do is perpetually be learning. And if I'm farming off the learning or the hard part or the routine part that helps me learn to the AI, I might very well be short-circuiting the thing that God has designed me to do if I'm not careful.
Well, I mean, we've both gotten physics degrees, and I don't know how you were taught physics, but when I took electromagnetic theory, they introduced us to these 300 equations, made sure that we were fluent with those equations so we could solve everything. Then at the very end, they introduced us to Maxwell's 4 equations and basically said, with these 4 equations, you can save a ton of time. But they wanted us to understand the basic electromagnetic theory before we got to this quick, easy tool. And that made
I even remember that just with before I used calculators, I was taught how to do long division, how to take square roots, how to solve quadratic. Yeah, I mean, there's a whole slew of things that I was taught how to do, and then basically said, "Here's a," I learned here's a faster way to do what you know how to do now.
Well, I'm older than you, and I can remember when I was in elementary school, a few of us had slide rules, and the teacher says, "Put those slide rules away. I don't want you even touching a slide rule until you know the mathematics behind it."
Right.
And at the right time, you can start using your slide rule. And I remember a bunch of us approached our math teacher and said, "Hey, we learn this math faster. We'll let you use this." Says, "I'll make an exception. If you guys can get this all taken care of by the time you're in the 6th grade, I'll let you use the slide rule. But don't tell the other kids."
Right.
So,
Well,
and I think AI is the same, right?
No, I think it's true. Yeah.
If you understand how AI works, how the programming is done, if you have some basic understanding of the algorithms, you're going to be much more able to use the AI system in a way that'll get way more efficiency and trustworthy results than someone who doesn't understand that.
Well, and you're less likely to use it for poor things because I think the particular thing that I am concerned with about AIs out there today is that they seem so much like people. They seem to be, I mean, we use term like, oh, AI is thinking, AI is reasoning, AI is. I don't think those statements are correct. And if we're not, if Genesis 1 is correct, we are designed for relationship.
Right.
We look for ways to relate. The only reason we don't relate to a rock is because it gives no indication back that it's relating. But we relate to animals because they respond to that. We relate to one another because they respond. We relate to AI if we think it's relatable. And I don't, AIs are not building relationships like we are. And so, the whole point of, do you understand how it works? Do you understand what it's doing, both what it's capable of and what its limitations are? Then, I think there are so many cool things that AI, I think, will help us accomplish. I also have the suspicion that because maybe I'm just lazy, but I think people in general are lazy. And if we're just using this for efficiency, we're going to miss that the way to use this tool well is to use it so that we can do the next hard thing that we couldn't think of before, so that we're learning and advancing as opposed to just doing what we can quickly.
Well, just yesterday, Jeff, I read an AI article that talked about these men who had an AI companion, where you could talk to the AI companion and would empathetically respond to you, and how these men basically preferred to spend time with their AI companion as opposed to their wife.
Doesn't surprise me at all.
Well, it doesn't surprise me because, your wife is going to offend you once in a while. You can design the algorithm with the AI companion where it's never going to do that.
Right.
And so it's like, hey.
And they are designed that way,
They are designed that way.
Well, and I think that's part of the blessing of that command is be fruitful and multiply. Well, to be fruitful, you've got to be married, have relationship. You're building a relationship with your kid, with your wife. It seems like God often, in my experience, he takes two people and puts them together and says, well, you kind of are very different. Let's put you together and see if you can make this work. That it's designed to be challenging. That's actually part of the fun of I'm old enough now to recognize that that's part of the fun of the relationship. If my wife was just like me, it would get kind of boring. The fact that she's different is what makes it challenging and exciting at the same time. And so I think, to me, the concern with these AI companions is that you're never forced to grow. And I think God has designed us to always be growing.
Well, you see that in the New Testament epistles, that one of the ways we build intimate relationships is by responding to the offenses that come into our life. And if we never get exposed to those offenses, we lose out on that growth.
Right.
And so, when your wife offends you, it's important to dig in and say, what's going on here? I know women are hard to understand, but let me give it a go and see what's really. And so you talk to her and find, okay, I didn't understand what was going on here, and you basically correct that action.
And you build depth to the relationship as a result. Yeah.
And, unlike just being a bunch of algorithms that respond to databases, your wife actually has a capacity to reason.
Yeah.
And you do too. And so an AI companion, you won't get hurt emotionally, but you're not going to have the level of intimacy that you could have with a real human being, or for that matter, even with your pet dog.
I agree. And so this is, I've been trying to figure out as I've been wrestling with, thinking about AI from a Christian and apologetic perspective, is that I do think there's a lot of good things that can come out of it. I also think the rapidity with which it is advancing, I'm not sure we're trained to deal with or we're capable of dealing with. And so, like with a calculator, you can use a calculator and never learn how to do basic calculations. If you've got the maturity, you can learn how to do the basic calculations, and then you're using the calculator for something that couldn't be accomplished before. And so how do we develop this mindset of developing our maturity so we use it to work towards things that we're designed to do, as opposed to going off into arenas that
here's another perspective.
are destructive?
These AI systems, just like everything else in the universe, is subject to the second law of thermodynamics, which means a time will happen when your calculator isn't functioning the way it should. Now, if you understand the math, you can immediately spot, okay,
that's true,
my calculator is not functioning, so you get it fixed. Or like if the elevator, it doesn't get you to the right floor, okay, we need to repair this, figure out what's wrong. But if you have no understanding of the system, you don't know when thermodynamics is struck as actually making the system not do what it's supposed to do.
Yeah.
And by the way, thermodynamics is inevitable. You're not getting
no,
around
that
it.
is true. And
So,
all of that requires us maintaining our knowledge and increasing our learning. And, I think AI has got a great capacity to help us do that, as long as we maintain the desire to do the hard things to keep growing with
Or to
it.
put in a biblical perspective, we need to make sure we're always the ruler over AI rather than letting AI rule us.
I agree. Couldn't have said it better. Thanks. You appreciate that.
Great.
Well, I want to thank you for joining us today. I want to encourage you to drop down in the discussion below and join us in the comments down there as well. Like this video and subscribe for more content. We release new episodes of Star Cells and God each Wednesday here on YouTube and on your favorite podcast app. Make sure to share this video with a friend. Have a great conversation over it. And remember, the more we know about science, the more reasons we have to believe in the God of the Bible.